Okay, for today, it is about quadratic or absolute value inequalities. Let me help you understand. Imagine for a moment that you had a quadratic that you just wanted to be above 0. Well, first, I think it helps the most to figure out what that looks like as a picture. Can you imagine for a moment that that's a quadratic that, where are its roots, by the way? Well, right away, I think if you can factor it, you should. X plus 1, x plus 2. So the two roots are at -1 and -2. It's like there. And there's no negative in front, so I know it must be kind of like this. Now, remember, all I care about is where is it bigger than 0? Well, I can see that it's bigger than 0 in here and here. So how would I say that? Notice there's no y in my equation when I set it greater than 0. I just care about the x values. So if this is -1 and this is -2, when is that thing above 0? From -1 to infinity and from -infinity to 1. And I just made a mistake on purpose. Wait, to -2, sorry. I should have just at least done that. But I did a mistake on purpose. It's a small one. Who can catch what the small mistake is? Yes, ma'am?
It's not above 0, like right on those points it's at 0, so you need to do parentheses.
On these points, it is 0. Is 0 greater than 0? No, it's not. So I would need parentheses here and parentheses here. Yup. That's essentially the homework for tonight, is problems like that. What just happened? We found the two roots by factoring. Once we knew what the two roots were, the answer was going to be when xy's is this parabola bigger than 0? In here and here, which was, again, I'll do it in a different color here, all the way up until here. All the x values work till there, and then all the x values work after that. And so if you put that on a number line, it would look like this. Here's -2, here's -1, and it worked everywhere except between those two. And I wrote that in interval notation. All right. Can you imagine the same exact thing except it was a V shape instead of a U shape? Stay with me. I'm right here. And if I made a V shape, it would be just pretty much the same thing. So imagine for a moment I said this. Y equals absolute value of x plus 3, absolute value minus 1. Do you get that's a V shape that's been moved? What if I said, instead of equals y, what if I said is, no, how about this time, less than or equal to 0? First step, where is it? It's been shifted. Which way? Right, left, up, down?
Left.
It's been shifted how far? Left how far?
3.
3 to the left. All right. So you should be sketching this at this point. I'm able to see your iPads. I see several of you that are not sketching it. Please, get sketching. Don't make me call on you individually. All right, so where am I going to put this thing? 3 to the left and down 1. And so I'm going to 1, 2, 3 to the left and down 1. There's a little dot right there where my V would be. I missed just a little bit. I'm going to try harder this time to hit that spot. There we go. There's my V shape. And when is the V less than or equal to? I made it or equal to this time. Less than or equal to 0. There, and everywhere in between is where this function falls below or is equal to 0. And where is that spot? It's at -2 and -4. How could I have found those? Those are the places where it's equal to 0. How could I have found them by looking at this? So they aren't just super obvious, but they are the x-intercepts, right? Where it's equal to 0. So couldn't I have set this equal to 0 to find the zeros? Yeah, that'd be important. Every time you need the zeros. Okay, so what are the zeros on a parabola? That's when you'd factor it. And you can get the zeros that way. X plus 5, x plus 1. What are the zeros when you have an absolute value? You're tempted to say -7, -3. That's an important spot. Remember what that spot's called? The vertex. But the vertex is a good spot for remembering, like, oh, it's increasing from here to here. The vertex is really critical for that. But for these kind of problems that we're doing today, it's all about the zeros. What's another name for zero? Roots. Another name for that? X-intercepts, which are where what? Y equals 0. Look at, I'm going to put y equals 0, and then you just solve, and those will be the two numbers. And it'll always either be between those two numbers. Anybody do one of those two numbers in your head right now? What's going to make this thing equal 0? If x was what? -10 would work, because then this would become 3, which would then 3 minus 3 equals 0. But there's another thing. All right, -10 and -4 are the two answers, because -4 plus the 7 makes it +3, and either way it's 3, because it's absolute value. So, okay, and so here's -10, here's -4, and then it's either going to be like this in between them, or it's going to be like this. And then the endpoints, you decide those based on whether the person wants you to make it greater than or equal to, or just greater than. Because if it says or equal to, you'd fill in these spots. All right, there's a quick summary of what's happening for this lesson. So now let's look a few more in. Reminder that we still have a tennis ball lab out there, and we definitely will grade that. Get to, everybody knows greater than and less than, so let's get to this slide, this green one. Everybody get there. It's a few slides down. I'm saying most people are there. Okay, good. All right. Now, the graphs of F and G are below. The one that's darker, this one right here, that one is G, and the F graph is this one. One of them is a parabola, one of them is a U-shape. Anybody want to predict what's different this time? This is one of those where it's really complicated to explain, but I think you understand. You're going to be comparing what's bigger than what. Instead of bigger than 0, now you're going to say, when is this function bigger than this function? All right, so let's color them as it says here. Let's color in these different functions in different colors, and then it'll help to say, like, when is the yellow line below the blue line, that kind of thing. All right, so it says put in stars. F of x equals g of x. We graph both sides and see where they cross or where they intersect. And so stars, I want to put a star here and a star here. If I just cared where they were equal to each other, that's where the one function equals the other function. Okay, it says color with blue, where f of x is less than g of x. Yeah, I'm going to give you a hint. Less than means below. Where is, and I'll use different colors yet, like red. Where is, that's f of x. Where is the red function below the black function? That's the question. I would think of it this way. But really, it's like from here over. And those are the x values. And so, I need to clear out a little space here. See that guy? My x value is between -1 and 1. But this time my answer is the one that's on the outside. Again, I like to think of it as a number line. So here's -1 and here's 1. And the answer we just did in blue there would be empty spot, because at that spot it is equal. And we don't want it equal, we want it less than. And in the outward directions is where the blue function is really less or below the black function. Could I have written that with interval? Sure. -infinity to -1, union 1 to infinity. I strongly recommend making a single number line. It'll remind you we're talking about just the x values here. The answers are x values. So if you make a number line to answer these, like I just did right here, it'll help you to write your final answer as interval notation. All right, and it says color with yellow where f of x is greater than or equal to g of x. Switching to yellow, where is f of x, the lighter colored line? Inside there. And that whole little range is where the f of x function is bigger than the g of x function. And so we know what the two key spots are. Here, oop, I should circle that better. Here and here. And so same deal, it's this number line, except now the answer is between here and here. So I would say it was from -1 to 1. And it doesn't say or equal. Oh, it does say or equal to. Yay, I get a chance to practice that. It says or equal to, so then I bracket this. Because at those spots, those functions are equal. All right. Let's see if you can handle this. This one says, where is this function greater than or equal to 3? Right off the bat, it's different. Do you get this as an absolute value that's been shifted 1 to the right? Sketch that. An absolute value shifted 1 to the right. Did you draw something like that? A V shape shifted 1 to the right? Then where's the other line? Help me. It's at 3. Okay. Where exactly is 3? Not sure. But guess what these starred spots are? The places where they are, where both sides are equal. So this is where you could do your little x minus 1 is greater than or equal to, or actually just say equal to, sorry. We just want to know where they're equal right this second. Equals, oh, let's just back that up, sorry, x minus 1 is equal to 3, and x minus 1 is equal to -3. And I would solve x equals 4, x equals -2. So those are the two key spots, -2 and 4. And those are the x equal spots. Now, your answer is either what's in between -2 and 4, or what's outside of -2 and 4. Again, I like the number line. I'm drawing one. Here's -2, here's 4. And when do I want it? Do I want it what's in between the two? Think it through. I want the absolute value is bigger than 3. Do I want between my two key numbers or outside of my two key numbers? Outside of it. Yep, it's like this. So the answer then is from infinity to -2, union with 4 to infinity. All right, let's look down at this one. Look at number 4, everybody. The first one's super easy. It's just a V shape shifted 1 to the left again. Hold on. The other one, not so easy. Do you remember that this could be written as 1/2 x plus 2 if you divide them up separately? Do you get that that is a line that goes through 2? Which, by the way, is right there. Because this spot is at positive 1. Know how I knew? Because I put in x equals 0 to check quick. This spot was at 1, so this spot would be 2. And it's got a slope of 1/2. A slope of 1/2 means that it's fairly flat. It's not as steep as a slope of 1. Well, a slope of 1 would be like that. So it's not that steep, but it is positive. It's going to be kind of like that. Look at that. There's going to be 2 answers. Do you get by making a little sketch of it, I can tell? Could this have missed it entirely? Yeah, it's possible, and then there'd be no solution. Could it have hit only once? Yup. If it had been angled just right, it could have touched it only once, but I can tell this one's got 2 answers. Even though at first I was a little sketchy on what that thing was, now that I got a little quick sketch of it, I know there's going to be 2 answers. Can you solve it? Sure. You set up your 2 equations. X plus 1 is equal to x plus 4 over 2, and x plus 1 equals negative x plus 4 over 2. And you could solve those. And you'd know where your 2 key spots are. Okay, so what's the moral of the story for today? Graph both sides and see where they cross is a big deal. Second thing, knowing when 2 things intersect, those are going to be the key 2 numbers, and you're either going to say that the answer is between those 2 or outside of those 2 numbers. All right, next page.
Can you go back to the slide?
Yep, there it is.
So for the negative x plus 4, would that be in parentheses over 2 or no?
Good catch. This all should be in parentheses. And I also get this question all the time. Does that negative go on the top and the bottom, or just the top, or just the bottom, or what? That negative. What do you guys think?
Just the top.
Yes, you could technically do just the bottom, but most people will do just the top. And because it's only going to go on one or the other, they won't cancel. Do you get if you put a negative on the top and on the bottom, it would be like the negative was never there. It would just cancel away. So that's why you can't do it on the top and the bottom. You got to pick. And it actually doesn't matter, but most people do the top. So yes, thank you for reminding me about that. That negative should go to both. I was just trying to generally show you how to set it up, but I should have those parentheses there to make sure you don't do it wrong. All right. Yes, question. Move on. So this is taking steps for solving a quadratic inequality. You haven't seen one of those yet. I'm going to show you by doing it with you. First step, it says you're going to use sign diagrams, and it's true. That's the thing for today. You're going to verify your answer graphically. That means you don't really need to get your answer from the graph. You just kind of want to sketch the answer in the graph to make sure, like, should there be 2 answers or 1 answer or no answers. So let's just do the graph sketching first, because I think you can do that. Can you graph 2x squared? Just a rough sketch of what 2x squared looks like. Hint, that has not been shifted left or right at all. It's only been what? Stretched. Good. So maybe a little steeper than a normal parabola. Okay, how about this other line? Who can tell me a different way to write it so that people will understand it better? Negative x plus 3. Because now when you see it in that form, everybody's going to know it starts at 3, and then they might be able to process, ooh, it's a -1 slope. So it's got a slope of -1. If you look at this, doesn't really jump, the slope doesn't jump out at you that much. So I hope you can see how to do this one, and we graph it, hit about 3, and have a slope of -1. Looks kind of like that. Does this look to you like it ought to have 2 answers? Definitely. Okay, so now how do you get those answers algebraically? Any suggestions? Without my help, Imagine for a moment it's the ACT test, because this is fair game for the ACT. This is the question. The question isn't asking you to graph it. Now, you might be smart enough to graph it, to just kind of go, oh, I can see there's going to be two answers. It's a parabola and a straight line. Yeah, they'll touch twice. What do you think?
You get it on one side and then factor it.
Yes, you get it all to one side and then factor it, because if you can factor it, you should. And you can't factor it the way it is right now, but if you move it to one side, so let's get it all over to this side. Let me show you what I mean. I am going to add x to both sides, and I will have 2x squared plus x, and then might as well just get it over with. I'm also going to subtract 3 from both sides. Minus 3 is less than or equal to 0. Isn't that just like what we were doing a minute ago? Now you might ask, wait a minute, Mr. Server, you fundamentally changed how the graph's going to look. That's true. I have. Now it has a y-intercept of -3. And if I can factor it, I should. I really ought to figure out what those roots are going to be. So let's factor it. Two x and x. This is calling on those algebra skills, which I tried to make better by making you do the top 20. This is the moment where if I didn't do the top 20, in fact, there was no top 20 when I first came to high or honors pre-calc, a lot of kids start dying in the class right here because they don't know how to factor. And that's just like one little piece of a problem. And if you're like, but I don't know how to factor it, well, then you can't answer the question. So I started the top 20 because I noticed things like that, where partway into the class, kids' algebra skills were so weak that they couldn't do it. Get them fixed before that. All right. So now, did anybody figure out the combo? 2x plus what? Plus 3. Very good. And then minus what? 1. All right. So then what do you think these two spots are? Where x equals, one of them's positive, right? So the x equals what right there? 1. And how about the other one? Well, 2x plus 3 equals 0. 2x equals -3. X equals -3 over 2, which is the same as -1.5 if you like decimals. So then that one right there, x equals -1.5. And in the old days, we would have been done. But now, it's less than. These are the two spots, right? These are the two key spots. I'm going to put stars on them right there. Those are the two key spots. I want the parabola to be less than or under the line. Do you get that that's happening in this little place right here? The parabola is under the line. So am I saying between the two key numbers or outside of the two key numbers? Between the two key numbers is where the parabola is less than the line. Okay, so between here and here, which is, if I had a number line this way, -1.5 and 1. Green is terrible, isn't it? I'm going to make it so you can see that better. Here's -1.5, here's +1. And those spots themselves are called the zeros. If it ever says or equal to, which it does, see this one says less than or equal to, then you fill those in. Okay, now I want what's between here and here. So then I'm shading it in. So now I can pretty easily tell that my answer's from bracket -1.5 to 1 bracket. There's your zone that works. Okay, what were the steps? Man, this is why pre-calc is tough. The first thing was you had to know how to graph a parabola. You had to know how to rearrange a straight line here so that you could see it was a straight line with a slope. And then you were just started. You had sketched it and you knew there was going to touch twice. Then you had to actually solve it using algebra here. And if you can factor it, you should. And then you get your two answers, and then you got to know that it's either between those two answers or outside of those two answers. So there was, you could argue like 7 steps to answering this question. And if you wanted to break it down into like, first you got to sketch a parabola, then you got to sketch the straight line. You probably get it up to 10 steps. All right? That's why when people ask, why is pre-calc so much harder? It's because you have so many steps before you get the answer. In honors, higher algebra, I'd say the most steps you typically would have is maybe 4 to answer a question. And we just had, you could argue, 7 to 10 steps. Okay? All right. Let's go on to the next page. This is a good, simple, straightforward question. And the first thing I would do is sketch it, so you get an idea of what's going on. They didn't tell you you had to sketch it, but I'm telling you, it'd be very smart. Take a second and sketch it. Because sometimes the answer is no solution, and you'll get it right off the bat because you'll be like, huh, the 2 lines don't touch. When I say there's 2 equations, what am I talking about, Dragon? There's only 1 equation. It says x plus 3 absolute value is less than 5. How are there 2 equations actually?
Well, y equals absolute value plus 3
And y equals 5. You are correct. Those are the 2 that you need to graph. I was actually saying sketch. Okay? So generally, what do you got? Do you have a V shape and a line?
Yeah.
And are yours touching?
Yeah.
All right. I've got my V shape shifted left 3. And I got my y equals 5. Now, this is the tricky part. It's hard to know exactly where that y equals 5 goes, but it's somewhere in the neighborhood of, well, up there somewhere. Exactly where do they cross? That's not the goal right now. The goal is to just kind of see, oh, I do have 2 answers. Could this been arranged so that there was only 1 answer? Yeah, what if it's a V shape and the line just touched like this? And you can see, oh, there's only 1 answer for this one. All right, so you're just trying to get an idea of, is there an answer and kind of where is it? Okay, next, the critical spots, the zeros. This is the part where you just plain old-fashioned solve this thing. X plus 3 is less than 5. Now, I know some of you are like, but you said equals before. Let me just follow this one through, and I think you'll like this. X plus 3 is less than 5. And the other one, x plus 3 is, take a guess what I'm going to do, greater than negative 5. Yes. Easy mistake to make if you switch the sign around because the other ones become the opposite. It's like you times by negative 1, right? And wouldn't that make you switch the sign? Now, I know some of you are still stuck in the old way we did a minute ago, but I'm telling you, you're going to like this way. X is less than 2. Notice it says less than. I know it has to go to the left from the 2. And minus 3, x is greater than negative 8. Now, if I put it on a number line, here's my negative 8, here's my 2. Now I got a better idea where these guys are touching. And I can tell whether it's in between or outside. Because look, it says less than 2. That's got to be this way. And it's got to be bigger than negative 8. That's got to be this way. Do you get what I'm saying? I can tell it's between them. Now, there is some value to this testing intervals thing, but we're going to use it to check our answer. Do you get if it's a test? Or if you are designing the next prototype of the Tesla, it's probably important that you don't just like give it a guess and then give it to the boss. You better check it. Make sure you're not screwing something up because this could cost the company millions, or it could cause your satellite to crash or whatever. All right, so how do we test it? This is the test intervals part. I think the answer is between these two. Why don't I test a number that's between those two? Tell me a really easy number to test that's between negative 8 and 2. 0. Zero's in there. Now watch, I just stick the 0 in. I'm going to go up to the very top. I'm up here at the very top of the page, and I put in a 0. Did I make a true statement? Is the absolute value of 3 less than 5? Yeah, it worked. So now I know I did it right. Could I also have tested a number of bigger than 2? Sure, watch what happens. I tested a number bigger than 2, like 3. absolute value of 6 is less than 5. Doesn't work. Make sense? All right, so we're going to use that test intervals thing, but only to check our work. All right, moving on to this page. Act like I'm not here. Sketch it. Find the key spots where you think it crosses. And test it with, if you think the answer is between 3 and 7, test a number in there. Make sure it actually works. I'm going to pause for a second while you give this a try. Okay, we realized quickly that that one was the one we had done before. I apologize. Instead, let's get into your assignment. And I think you've got the idea, but the one that we were just about to do that was kind of like that, let's go to that one. I do want you to do problem, I was going to skip number 1 because I think it's a little too easy. I'm going to start with number 3 and then do number 6. Do both of those. Let's do 7 and 17.
We have a late
Yeah,
start.
we have a late start today.
Good to know. Good to know. Doesn't mean that we're not having the test. Thanks for letting me know, though. It's not, late start doesn't mean that the classes are 5 minutes long. I mean, it does cut out some time, but it doesn't cut out that much time. So I will see. If the test can't be done in that much time, we'll adjust. We'll do another lab or something, and then we'll take the test next week. But thanks for noting that. All right. That's all I have for the video for today. We talked about this one before. Within 4 units of 2. I think we should do 2 of those. I'll do one with you right now. I'm going to remind you. I'm going to give you one that's not it. But I'll remind you what it meant. This would mean that it was less than 2 distance from 5. Know what I'm talking about? This is the distance. This is what it's from. So if you were on a number line, you're saying, here's a 5. I want the things that are less than 2 away. Well, that would be 7 on this end or 3 on that end. And so this little statement would be that these are the things that are less than 2 away from 5. So can you make one that is less than 4 units from 2? All right, try that for 39 and 40. And I'm aware today's a little more challenging than normal. There. But remember, the test isn't until Friday. All right, and that's it. That's all I'm assigning. We're not going to do that. We're not doing that today. And this little Friday quiz thing.